a video, and also like you're supposed to write notes, right?
Yeah.
Okay, and I leave that to you. And camera?
Yeah, hold on, let me get some. Got it. Okay. Okay, I'm ready.
Yeah. And let's see, there are a few questions left. We should review the one that projectile page. Oh, let me show you one projectile like see, this is a projectile cannon. Can you see this cannon? You see this cannon, right?
Yeah.
And because it's a curve, it's kind of complicated. So we make, and you also learn like a vector adding, right? So we can also basically split one vector into two directions. So show you the vector form. See the green one?
Yeah.
Yeah, that basically make one velocity into two velocity, right? Does that make sense? Yeah, so that's why we have well, two directions. Wait, 36. Do you still know how to do 36? Let's just we did it in the last. We did it in the end using the formula, I guess. Do you know how to do 36? One is horizontal and one is vertical. So we separate into two kinds of. Anything else? 36 is a little bit ago in the beginning. We did 36. Let's just see what how much you remember.
Uh,
45, and it basically goes something like this. But this is complicated, so we make one horizontal.
so then there's the vertical.
And
So the
then vertical.
horizontal is like, I remember horizontal is cosine, right? So it's like cosine 45 times 10.
Yeah, cosine 45. This is this. So which is 10 cosine 45, and the formula is time t, which is the distance, which is the range we're gonna find, right? Horizontal distance. Horizontal basically it's just something like this, horizontal. And then vertical, it's going up and then down, right?
Yeah.
So how to find the vertical?
Gravity, it's just 9.5 meter per second. Right.
9.5. What do you mean by 9.5? Why 9.5? You mean 9.8?
No, yeah, 9.8.
Oh,
My
yeah.
bad.
Yeah, so which is, we're going to use the g acceleration, right?
Yeah.
With the g acceleration, how do you use that? Which formula are you going to use? We have a formula delta y, which equals to v0 y times t minus 1 over 2 gt squared. This is the, I said it in a hurry last time in the end.
Yeah.
So how do you express that in this one?
No.
Right?
A second. We got delta y.
What's delta y for this one? What's delta y for this one?
45.
Yeah, also negative 45, right? So going up
negative
and
45.
down, right? So we suppose going up is positive, so that's negative 45 equals to what's v v0 y?
That's v0 of y. That's just
Hmm.
uh
v0 x is v0 y, right?
that's just 45.
Yeah. Wait, you mean 45 degree, right?
Yeah.
45 degrees. So what's v0 y?
That's sine
Yeah,
45.
sine. 10 sine 45, right?
Mm-hmm.
We're going to use it later, so I might write this one completely. And time t, we don't know, right?
Yeah.
And plus, and also I guess minus, right? That's just
Yeah.
minus 1 over 2g, which is 5, right?
5. Yeah. 5t squared.
And so we have this system of equation. Which one you want to solve first? I have two equations. Which one you want to solve first?
Top one.
Although it's easy, but you have two variables, so we
Oh
can't
yeah.
solve it, right?
That's
So
just the bottom one. It's just
yeah, let's do the second
yeah.
one.
It's gonna be negative 45 equals to 10 times root 2 over 2. That's just 5 root 2 of t minus
Yeah,
5t squared. So it's gonna be 5t squared minus 5 root 2 t minus 45 equals 0.
yeah.
And
Do you have the calculator with you? Use the
just
calculator.
quadratic formula.
Yeah. And then you can find the t, right?
Yeah.
You probably have two t. One is probably 0 or something. And the other one, I mean, 0 or like a negative. Maybe you have to give up one. And maybe you can take 2. Does that make sense?
Yeah. Yeah.
What's the time?
t is 3.8.
3.8, right?
Yeah.
The t is 3.8. And then you can substitute this t to
Yeah.
the equation
So
1, right?
10 cosine 45.
Yeah.
That's just root 2, 5 root 2 times
Yeah.
3.8.
It means 3.8, right?
Yeah, it's 5.2. Yeah, that's gonna be like 27.
27. Okay, great. So this is the way to go. I almost always like that projectile. We need these two equations, one vertical and one horizontal. Let's go on with this. This is 36 and 34. Go to 34.
All right.
I guess it's American football, a place kicker.
What can I wait? No,
Huh?
no. So
You can write on my screen. Can you write on my screen?
yeah.
And we can write on my screen. Yes,
So
Go to 34.
you have some football here.
Yeah,
Angle of 30 degrees on the horizontal.
yeah.
10 meters per second. Velocity equals to 10 meters per second.
Yeah.
How long will it stay in the air? So it's gonna be like, and then
Yeah. Yeah.
so we're gonna calculate the t
Yeah. So what's the t? How to find the t?
until the y reaches 0.
Yeah, dot y is 0, right? Great. Very good observation. So dot y is 0. So can you get the which equation you want to list?
Let's do the first one. So horizontal, it's gonna be 10 times cosine of no, yeah, it's cosine of 45.
Wait, this is a 30 degree, you mean? Last time
Oh
it's
no,
45.
30 degree.
Hmm.
Yeah, cosine of 30 degree times t, it equals to the range. We don't have that.
We don't have that. So we can leave it there. 2 minute variable.
And then delta y, that's just 0
Yes,
equals
0.
to v0 y. V0 y, uh that's 10 times sine of 30.
Yeah, sine 30 degrees.
B minus 1/2 of y. G, no, that's just 5t squared.
Yeah.
Yeah, we'll get t from here. Hold on.
Oh, this one we can do with factorization because there is a 0 on the other side. We can use factorization. There is a common factor 5t, right?
Mm-hmm.
Because sine 30 degree, I believe is 0.5 or 1/2. So eventually t is 1, right?
Yeah.
And of course t is 0, it also works, but that's
Why
obvious.
is it why
Hmm?
1? Why t is 1?
Oh, I'm making t times sine 30 degree into 10 times 1/5 and 1/2, which is 5.
Yeah.
So basically it's 5t minus 5t squared. So I'm using
Oh, yeah.
factorization. 5t out, and then it's 1 minus t inside. Does that make
So
sense?
t equals to 1 or 0.
Yeah.
So
0, yeah, 0, it is
it's
making sense, right? 0, you're in
Yes.
here, of course, your displacement
gonna
0.
be d. Yeah, I get it.
Yeah, it's d, right? So this is another projectile. 31. One
I
object
don't
at,
understand this question.
hmm?
I didn't understand this
Oh,
question.
it's not exactly the same thing as you did as the previous one. An object at, we have to draw this. He said at 35-meter position of one-dimensional coordinate. So one-dimensional coordinate is just like this, yes. And they said there's a 35 meter, which means there's a, let's say there's a 35, and that's, he starts at this. Does that make sense? Right
Yeah.
now he's in here. It's moving in negative direction, which means in here, right? But
Yeah.
this is positive direction
Constant
number.
speed of 25 meter.
Yeah. Which function best represents the car's position x in meters on a coordinate system?
So there's no acceleration.
Yeah, it's constant velocity, so no acceleration.
So wait, what's the position formula again?
Position formula is just it's basic displacement function. It's a delta x equals to vt.
Yeah, delta x equals to vt. So velocity is negative 25 meters per second times time.
Yeah.
It's just t.
And delta t this time we
Plus
have
35.
to. Yeah. And we normally use x minus x0 equals to delta t. X is your final position. X0 is your initial position, which is 35. But even x minus 35 is that, so same thing as you plus 35, right?
Mm-hmm.
Yeah. So which is gonna be A, right?
Yeah.
Yeah. So this one you can remember this. Also, there might be another kind of formula which can be right x minus x0 equals to vt. This is constant velocity, or x equals to x0 plus vt, which is basically what you did, right?
Yeah.
You plus 35, you're using that one. So this is a 31.
All right. Next
Basi-
question.
Yeah. So it's not big 5. It's not constant acceleration. It's a constant velocity. 25.
Ooh.
I don't think we have graph. We have skipped 25, I think. 22. You need graph to do 25. So 22.
An object free falls from rest a distance d in a given amount of time. How far? So it's like
Yeah. G.
Is there a horizontal direction or no? It's just
No,
big.
this is free fall is just the Newton's apple falling, right? Free fall.
Oh yeah. How far will the object fall from rest in twice? Yeah. Does this like count from like the terminal velocity? Or just
Terminal velocity.
or is
Not
it
exactly.
because like it's like acceleration is uh meter per second square. That's squared. So it's gonna be 4.
Haha, you think about square.
Like
Well,
2 squared is 4 because it's
how
twice.
far away the same as 4? Twice. Kind of. But we need to prove that. But that's a good, yeah, that's a good spot that you just said it. Actually, we can just, because it's G acceleration, right?
Yeah,
It's G
9.5.
acceleration. So it's gonna be big phi, right?
Yeah.
Acceleration. So this time is T, this time is 2T. So before it's delta X or delta Y equals to 0 times T, because free fall is, beginning, the initial velocity is 0.
Plus
1 over 2 gt squared. And this time, delta y saying the second, this is first, this is the second, is going to be 1 over 2 g2t squared, right?
yeah, so it's 4t.
Yeah, that's 4. Just use the big phi, right?
Yeah.
Substitute everything. And free fall, with it means it's just 0 initial velocity.
Okay,
Question
so
20
it's
to 113.
projectiles.
Hmm.
No air drag.
Hmm.
4 projectiles. We got projectile 1, projectile 2, projectile 3, projectile 4.
Hmm.
Okay. Do we have to use big 5 here?
Well, for the first question, let's take a look at the first question. 20, rank the vertical acceleration of the 4 projectile. What is the acceleration?
I think it's the same because it's all for gravity. It's all 9.
Yeah, all G acceleration, great. So it'll be C,
So
right?
it's gonna be C.
Yeah,
Oh,
C. We don't have to
all right.
calculate when it's a property phenomenon.
Okay.
And then 21.
Wait, is this like FRQ?
What do you mean FRQ?
Where's like where's the answer choice?
Oh, this is a 21. He wants you to determine the value of the
Oh,
greatest horizontal range.
so you just calculate it. Wait, can I go CP1?
Oh,
I
no.
think. Yeah, okay. P1, that's the P. That's initial velocity 40.
Yeah.
P2 45. 40. P3 60. 20. And P4 is just go up, right?
Yeah.
That's 10. So we can just eliminate P4
Yeah.
because there's no air drag.
Yeah. There's well, but there's no horizontal range for P4,
Yeah.
right? It's only vertical.
Oops. Okay, there.
Hmm.
So this one is just range. We can just calculate the horizontal range. So it's gonna be cosine of 60. That's just 1/2 times 20. That's just 10. So this is gonna be 10.
I'm
This
gonna stop you for a second. It's because we're gonna have this kind of question later, so we might, let's say, we might use formula for this, because if you use all the numbers, you have to do that question again. You don't have to memorize this formula, but there is a certain, so let me change this a little bit. Otherwise, you have to do 3 times. So let's just say this one is V0, and this is theta. So can you tell me how to find the range? Change this
Yeah,
question.
range, that's just cosine theta times
Yes,
V0.
yes. Time t, right?
Yeah, times t.
And how to find t?
We can,
Yeah, get the t.
oh no, we don't
Yeah,
know.
there is a t. We can get t because vertically you can also have a equation.
Oh, yeah.
It's
Vertical.
yeah, it's all in this kind of way. So delta y is 0, right?
Mm-hmm.
It's all in this kind of way. So delta y is always 0, right? So delta y equals to 0 and equals to v0y, which is v0 times sine theta, right?
Mm-hmm.
And minus 1 over 2 gt squared, right?
Yeah.
Does that make sense? And also, this is a little tricky because the projector thing is a little difficult to do, right? Also, not that difficult though. I can still do this because this is 0, right?
Mm-hmm.
I can get the t out. It's v sine theta minus the, well, if I get it here, minus 1 over 2g, right?
Mm-hmm.
T equals to 0. Does that make sense? Does this make sense?
Mm-hmm.
It's the same factorization we just did it a little while ago. So t is 0 is okay. And the other choice is 1 over 2 gt equals to v0 sine theta. So which means t equals to v0 sine theta, well, time 2 and over g. Does that make sense?
Mm-hmm.
Does that make sense?
Yeah.
So now we have the formula for this. Only this kind of situation. So there's a formula. R equals to v0 cos theta. See? You'll have this in here, right? And
Yeah.
time the t in here, which is 2v0 sine theta over g, right? So if I somehow simplify, that'll be 2v0 squared over g time sine theta over and time cos theta, right?
Mm-hmm.
And since I have 2 in here, I can use, have you learned trigonometry?
Yeah.
So this, have you learned there's a formula for 2 sine theta cos theta?
Yeah,
It's
that's just cos that. Wait, hold on.
sine
That's just
2
two.
theta, right?
Yeah.
Is it sine 2
That's
theta?
yeah.
So it's sine 2 theta. See, now you can know. So it's gonna be decided by, well, v0 squared times sine 2 theta. You just see which one is greater. You can substitute all the numbers. Does that make sense?
Mm-hmm.
Well, basically, we can do, I think P1 and P2, we can compare a little bit because V0 is the same for that one, right? And sine 2 theta of this one is sine 60 degree, and this is sine 90 degree. I guess this one is greater, right? So that one is 1. That one is, well, at least definitely less than 1, right? So P2 is definitely greater than P1. Does that make sense?
Mm-hmm.
How about I think P3 also less than P2. See? Does that make sense? Because your 20 square is definitely less than 40 square, right? And then your sine, like 2 theta, which means sine 120 degree, also less than 1. So P2 would be the answer. Does that make sense?
Yeah.
So if you remember, there is a certain kind of question we will see eventually. It's just if V0 is certain in this kind of situation, if V0 is certain, sine 2 theta is like theta is 25 is going to get my maximum value. You can also find this in pre-calculus. And it's also a math problem there. Does that make any sense?
Yeah.
So P2 would be the answer. And also you should find that you substitute all the value, right? Oh, it's there. It's a choosing question. I thought we were playing out. Did this one okay? 21?
Yeah.
No. And it's better to, you don't have to memorize it, but well, we're going to use it later, so I'm going to keep this. 16. Photogate. Have you seen Photogate?
No.
Let me type Photogate to see, like, to see the picture. Photo. It's not the Photogate I want. See change. Here. That's the Photogate.
Okay.
Which means the one they have a little like a rod thing, I think. When you first arrive here, before there's a laser here, and when you cover, suddenly they detect something is here. With the moment you arrive, you detect something is here, which is covering the laser. Does that make sense?
Mm-hmm.
And then after that, after the entire rod, passing that, which is going to be, well, can you imagine this? Let me draw this one a little bit better. Saying this is a laser. Before you get here, this is the moment you start to count. And after you get this laser here, and you, after, a very short of time, because they have good sensors, I guess, okay. So it's become something in here. Does that make sense? So when is the one that, what is the time you cover the laser? Which is going to be the diameter. Does that make sense? You just move the diameter, cover the whole laser. Does that make sense? Kind of like that. So which means this is how they calculate the instantaneous velocity. This velocity at that moment in a very short time. But thank God we have this kind of good detective, devices thing right now. So for Photogate 1, how do I find it? Using a 1.2 diameter divided by 0.02, which is the V initial velocity. Does that mean?
Okay.
It's always going to be like, it's like a routine. 1.2, but I have to use centimeter. No, I have to use meter. So, I guess this one is going to be canceled. True. So it's 0.6 then. Does that mean? So Photogate is the one that we use to find the instantaneous velocity. The velocity at that time. In that very little short of time. And for the second Photogate, well, this time is also the same 1.2 times 10 to the because same rod, right? It's also divided by 0.06 this time, which is 0.2. This is meter per second, meter per second. Does that make sense?
Mm-hmm.
And they said based on that this data and the fact that the photogates are 20 centimeters apart, which means when you're passing it in here, and when you're passing it in here, and there's 20 centimeter, which is 0.2 meter, right?
Mm-hmm.
0.2 meter is just delta x, right? And they want to find the motion, let me calculate the magnitude acceleration, which means they consider there is a acceleration or average acceleration or just uniform acceleration. Someone asked me, they about this question, they didn't really say it's constant acceleration. How do I know? It's assumption. Does that make sense?
Yeah.
They either I can consider its average acceleration or I consider uniform acceleration. Also, this is a routine thing we do in PhotoGate. So suppose that they have acceleration. And so that's what they want to know. And also, we know V initial and we know V final, right? Is there any formula you remember? It's a uniform acceleration or average acceleration. One of the big five that we can actually use in here.
Big five?
Yeah, one of the big five. Do you have big five formula sheet? Is there a sheet?
Yeah.
You can check which formula involved with dot x and acceleration and V initial and V final. No time, especially. So we don't really know the time for this one. We don't really know the time from one, photo gate to the other photo gate. This is the least popular formula, which is number 5. See number 5? Number 5 is the only formula that does not have time, right? All the other 4 formula have time. So when you don't have time, you probably use number 5.
The number 5, yeah.
Yeah.
So bf squared minus bi squared equals 2a delta.
Yeah, it's just 0.2 is in the end, the final squared minus 0.6 squared equals to 2a 0.2. Does it make sense? Okay, so this is the one. Use calculator, so there's that 0.20, 30. That's a 0.32 divided by 0.4. What's the result for this one? You also write it on the screen. First, it's speeding up or speeding down.
Yeah.
Which one? Is speeding up or speeding down? I mean, speeding up or slowing down? Speeding down, that's a string. Which means it's going to be decided whether your A is positive or negative. What do you think do you think A is negative or A is positive?
Positive.
Well, the V
negative.
final square equals to V initial square plus 2A dot x. Or sometimes we write it like this. Actually, I'm more familiar with this. So if this one is actually working with all like vectors, so you just substitute everything. 0.2, we have to decide. 0.2, 0.6, which one is the final velocity? Actually, it's a 0.2.
Slowing down.
Yeah, it's slowing down. So it's 0.2 square minus 0.6 square, which is negative, right? And also that 2a dot x is positive, right? We assume going to the right is positive normally, right? Yeah. So eventually A is negative, so it must be slowing down. You have to choose 0.5 or 0.8. Can you do the calculation? Maybe on my screen?
Yeah, just
solve this equation basically. And this is dot x is 0.2, 20 centimeter. With 0.2 meter.
0.8.
Yes, so which is D, yes, slowing down. So for this kind of, you have to be careful which is the final, which is the initial velocity. Does that make sense?
Can I go to the bathroom real quick? I'm back. Hello?
Right. Good. So that's 16. Oh, that's the last question from your sheet. It's 20. I'm going to use the formula that we used. Let's get 20. I mean 12 actually. How to do 12? This one sounds familiar, right?
Yeah, it starts with the previous one.
Do you remember the formula?
It was like y equals b cosine theta minus g times time squared.
Yeah, that one. There is a final one of the range, which is v0 squared. Remember that? Over g times sine 2 theta. Do you remember that one?
Oh yeah.
We use the v. This is the thing. V0 here, and here is theta. Now we're talking about this kind of motion. And this range we deduce all the way using all variables. So in the purpose of 12, actually. See, if we deduce all the way, for 12, it's v0 squared over g. It's basically a constant number, right? He said velocity is the same, right?
Velocity, so it's the same. So we don't have to care about that.
Yeah. So all we care is sine 2 theta. It's going to decide my range, right? That's going to decide my range, right?
That's just 2 cosine theta sine theta.
Yeah. So now technically this is a 1 theta. This is the other theta. As long that sine 2 theta is the same, you have the same range, right? Which sine 2 theta is the same?
C, because cosine 30 equals sine 30.
Wait, let me think.
Cosine 30 equals sine 60.
Yeah, this is sine 60, right? And this is sine 2 times 60 is sine 120, right?
Yeah.
Which is this is a 60 degree. This is 120 degree. Yes, I guess. So C would be the right answer, right? It's kind of like this. If we draw it, it would be like this. Although you have 60 in here, and you go in there, and also you have 30 in here, you go in here. Does that make sense? Let's see whether other things are possible. So this is if you 2 theta, it just means 20, right? 2 theta is 40, so definitely not the same. 2 theta is 60, 2 theta is 90, not the same. 2 theta is 90, 2 theta is 120. Also, ABC is really sine 2 theta are different. So C is the only choice, right? So is 12 okay? You think you can remember this? Maybe you can write down this sine 2 theta, but you have to draw a picture. It only works in this kind of situation. That makes sense? It only works in here. So V0 and theta is the initial angle. And we talk about when you hit the ground, what's the range? Okay, this is this. Let's return to the textbook that I sent you. You don't have other like questions, right? We can let's see, is there anything? I think for the kinematics, you almost finished. I think most of them at least. And then we can do well, dynamics. There is a certain questions I think you haven't covered. Let's just see. Have you learned like I said a little something about this force diagram. Are you familiar with force diagram, free body diagram? You learned this before, right?
Which one?
Free body diagram.
No.
Draw all the forces. No.
No.
Now let's do this then. Draw a free body diagram for each of the following situations, which means draw all the forces. Draw all the forces for each graph.
Right.
Yes.
And so Stickman's foot kicked the body.
Yeah.
So force there, and then Newton's third law, equal force. And
Oh, Newton's third law. Well, he is thinking about let me think. You think about the box, I think. We normally talk about one object have forces. So for the first one, for example, we probably draw it saying it's the center of the mass, and this is the normal force, and this is the
okay.
gravity. So we normally give it a name. Okay. So think about the block. Don't think about the person. It's not talking about Newton's third law. Just think about what forces are there on the block.
So there's goes there. I don't know what that force is called.
Well, let's just say if it is coming from foot, right? F foot.
Yeah, and then there's another one, F friction.
Let's see. Is there friction? Yeah, there might be friction.
And then force gravity and force Newton. Or no, force neutral. Neutral force.
We normally don't want to think about friction. Why? Let me tell you something. You're right to think about a friction. There's friction everywhere. Like no friction world almost doesn't exist in real life, right? But here in our AP1, when they do not talk about friction, we assume there's no friction. Does that make sense?
Okay.
So this one he didn't say. For example, for the E question, they say friction, and then we say there is friction. Does that make sense?
Okay.
We think of ideal situation. So
So
no
there's
friction.
F foot and natural force and then
yeah, so FG and F normal. Okay, that's this one. How about C?
Of force of going there. F natural normal force and the force of gravity.
Yeah.
Since I don't think there's a force of friction.
Well, they slide with the constant velocity. This one, they really doesn't say anything about friction.
Okay, then if it's constant velocity, then there's no force there, because right, it's just constant.
Yeah, it's just kind of consider it's somehow like what? Like ice, right? Perfect ice in there. Right?
Then there's no force because there's no acceleration.
Yeah.
The box slides through a rough patch and slows down due to friction. So force friction, normal force, and force of gravity.
Yeah, great.
Slides of a ramp with friction. There's the gravity. That's a perpendicular force, I think.
Oh, gravity. Let me draw Earth. The Earth we consider is a big circle. I mean, big sphere, right?
So it's going down like that.
So it's actually perpendicular to the surface of the Earth, but we assume it's always, so the center is in here. Yes, it's always vertical. Does that make sense?
Yeah.
So don't go for the perpendicular.
And then the normal force is like that.
Yes.
And then slides up a ramp with friction.
Yeah, so this thing means they go in that direction, right?
Oh.
Wait, let me think. This thing he goes in that direction, right? That's why there is something stopping him, right?
Yeah, so it's like that. F of friction.
Yeah.
So slides back down the ramp with friction. So there's friction.
Yeah, it's the opposite direction. Great.
The center of the Earth. And the perpendicular. Yeah. natural.
Yes.
No.
Yeah, perpendicular to the surface, which is the normal force. Great.
Okay.
So this is the free body diagram. So which is very important because remember we need sigma f, right? Only when you draw the force diagram, which means when you're confused or when you don't totally know the question, you should always draw the invisible free force, like
Okay.
free body diagram, and then you can find sigma f. So this is okay. How about this? And you already finished the poly. Let's skip this. Oh, here is inclined plane. Have you learned this?
Not for physics.
Okay, let's do 18 then. A block slides down a frictionless inclined plane, which makes a 30-degree angle with the horizontal. Find acceleration of this block, which is the free body diagram we just did it, right? You just draw this a little while ago, right?
Yeah. So we got the force diagram.
Yeah. Draw that again, and I'm gonna use some of that.
How do you calculate the acceleration?
So this is the thing. We have to think about in two directions. As you said it, perpendicular is for normal, right? You perpendicular to the surface, right? So in that situation, I have a right angle, right? So this is a right angle in here, right? So I want to use it because it's good for my like a trigonometry, which is good for calculation. There's other method, and this is the typical way. So because this is perpendicular, and also because let's think about this. Is this block going into the slope? No, right?
Yeah.
And also, is this block flying away from the slope? Also, no. Which means in this perpendicular direction,
There's no, the forces are equal.
yeah, so Newton's first law is working in here, right?
Yeah.
So if the Newton's first law is working, which is good for us, so which means this one is going to be balanced. We have the forces in here, right? You draw this line. What is balancing the normal force? Can you guess? The normal force, there's a normal force. What is the what is this force? Because when you draw it, we don't really have it. Yeah, it's gravity, but it's not exactly gravity. It's the component of the gravity. Does that make sense?
What?
This is your gravity, right? Is it making sense a little?
Yeah.
And
So
also,
it's like a vector.
yeah, it's a vector. So there is another vector which is causing us accelerate in that direction down the slope, right?
So it's like this diagram. There's this component and this component.
Yeah, exactly. So this one is balancing with the normal force, and this one, this vector is causing me accelerating downward, right? Along the slope, right?
Ah, okay. I get it.
So in this one, it balanced. It doesn't really matter for this question, right? So F normal equals to my mg cosine theta. Oh, I might want to explain why this one is theta. This one is theta, obviously, they told us. Why this one is theta? Let me explain. Can you prove? Maybe you can prove
Is it similar triangles?
Yeah, they are similar to triangles. So, which means or I can just expand that. You see, this angle at this angle is 90, right? Because this is 90, right? And this angle also at this angle is also 90, right? So this one must equal to this one. Does that make sense?
Wait, what?
Let me draw this in a better way. I expand gravity and expand this perpendicular line here. So I want to say this one is alpha. Let's say this one is beta. So theta plus alpha is 90 is because this one is 90, right? Because this is the right triangle perpendicular to the slope. And also because this is the gravity, so beta times this gravity. So this is so beta plus alpha.
Yeah.
I mean beta plus alpha. So that's why alpha beta equals to theta, right? So this one is theta. So that's why we have cosine, mg cosine theta, mg sine theta. Does that make sense?
Yeah.
Okay, can you do the question? Because I say this one balanced. So the only vector here is this
Okay,
mg sine theta.
Yeah. So sine theta, that's just sine of 30 degrees.
Yeah.
And then that's just 1/2. And then
Yeah.
gravity is 10, so it's just 5 meters second squared.
Yes, divided by m, right? So g acceleration in this kind of situation is my acceleration, right? And that explains our feeling. So which means the higher the angle, the higher the sine theta goes, right? So we get afraid, right? Because it's steep, right? And g acceleration is pretty much the same all the time. I mean, generally, except let's see, this is 18. Oh, you can try to memorize this. Mg cosine theta, mg sine theta.
Okay.
That's the two component of the gravity. So 19. Oh, 19, I have to mention something. Coefficient of kinetic friction. Have you learned this? Coefficient of kinetic friction. Have you learned this?
No.
Yeah, then let's stop for a second. Let me explain this. For example, if there's a block in here, if I push it, say it's not a perfect, like a frictionless, so there must be friction. When I push it, something happens. If it is get heavier, I can say more friction, right? Which means kind of like a gravity is going to influence that, right? But actually, it's not the gravity. For example, if I push this in here, and so my force is in here, but this one does not going down because of the gravity. So there must be a friction upward, right?
Yeah.
So in that case, so what matters is not gravity, but actually is the force that you give to the surface, which is the normal force that matters. Does that make sense? So with same situation here is only because your normal force is balancing with your g gravity. So F normal is going to be influencing my friction. Does that make sense? Which means more friction. I mean, more normal, more friction. Does that make sense?
Yeah.
Have you learned this?
No.
This sign is proportional. Have you learned proportional sign? So more this, more that. That's basically divided, with the same constant k something. And the other thing is influencing it. If it is ice, I say there's almost no friction, right? If it is rough, then there's more friction, right? So the other thing which is influencing friction is going to be how rough is the surface in between. Does that make sense? Does that make sense? How rough is the surface? Which we give it mu, which is what they gave us, which is the coefficient of kinetic friction, which means there's the formula friction F. Let me write it. F friction is going to be my mu Fn. Does that make sense? Mu is going to be my kinetic friction coefficient, which is how rough that is. The different material is going to decide that, I guess. And then also including like weather or something. And there's a normal then. Can you do this question then, 19? Because we have this friction then. Using normal and mu.
The mu is the coefficient of kinetic.
Yeah, which is 0.3 in here.
What's the no? What's the?
Oh, yes, good one. Normal force is something we don't really know. We have to draw the force diagram, right? It's a little complicated. So this is the normal force, right?
Yeah.
And also it satisfies the Newton's first law in this direction, right? Because it's not going anywhere in this direction, right? There's no velocity in this direction, but acceleration is 0. So this one, isn't that we said is mg cos theta, right? Because of the gravity, right? Component. Yeah. So it balanced with that. So this one must be mg cos theta. Not all the time, but in this situation, right?
Yeah.
If that's the case, I can just substitute this one in here. 0.3 and mg cos theta, right? Is my friction times 0.3. Does that make sense? My F normal.
So it's like the normal force is basically the vector of gravity.
Yes. Well, the normal force, normally we always get it with the force diagram.
Oh, okay.
With
okay.
basically whatever press you press it back. That's the normal force, right?
So
the gravity press it with mg cos theta, so the ground give it back by mg cos theta.
So we have the force, so that's just gravity sine 30 degree. We basically did that.
Yeah, yeah.
And that was just hold on a second. 5 meters per second square. That's the acceleration. And the coefficient of connection is 0.3. So it's just 0.3 gravity times cosine of theta. Cosine of theta is just root 3 over 2 times.
Wait, why are you using 5? Well, technically we can't really use 5. And last time, that's the acceleration for last time. But you can use mg sine theta. Because in this direction, this is mg sine theta.
Sine theta is just 5.
Oh, do you know m in this situation? I don't think you don't know. I don't think you know m.
No. What's
last time you
know? No. Yeah, we don't have the mass. So
because we're going to simplify it. Let's just leave it at mg sine theta there.
Okay.
We don't know m.
Mg sine theta.
Yeah.
Over m.
No, you have to minus the friction this time, right?
Minus the friction. The friction is just 0.3 mg's cosine theta.
Yes. And divided by m. You see? Divided by m and all m simplified, right?
Yeah.
Basically is, you can say somehow g sine theta minus 0.3 g cos theta, right?
Hold on a second.
Did it make sense?
Hold on a second. Okay.
So it's mg sine theta, basically g sine theta minus 0.3 g cos theta, right? You just got all the number with the, 30 degree. Okay. Does it make any sense? Since we haven't learned like friction, we might go back a little bit for friction. So it's a big thing in this period. Okay, here. There's 2 kinds of friction. We learned the second one already. See? This is the second one. So this is called kinetic friction. And this is mu k. K means kinetic. Fn is always normal force. But there's something else. It's called static friction and maximum. You know static? Do you know the relationship, the difference between static and kinetic? Kinetic means you're moving, right? What about static? What does static mean? Do you know what's static?
No.
Static means you're not moving. Does that make sense?
Okay.
You're not moving. Which means if I push this one, I might don't have the strength to push it, to make it move, right?
Yeah.
So when that happens, it's called, static friction. Does that make sense? Okay. So static friction, like mu, is a little bit actually it's a little bit bigger than that one. I mean, it's a little bit bigger than that one. And the time the normal force. You have to decide which one they'll talk about. Does that make sense?
Okay.
You know why they say the maximum is because when you are so big, you're gonna make it into kinetic friction, right? So this one is the maximum static friction. But if it's a little baby, saying if I get 20 Newton, it doesn't really work. It doesn't really go. And if a baby gives 10, like 5 Newton, still not working. So at this time, friction is 20, right? At this time, friction is 5. Does that make sense? Still pushing the same thing. They're not, all of them is not moving. All static friction. Does that make sense?
Wait, can you say it again?
Okay, so I'm pushing this. Well, I'm an adult. I pushed with a 20 Newton with this one, but it's too heavy. It's not moving. So it's static friction, right? So I give it a 20. So it's not moving. So Newton's first law is applying. So I give it a 20. So there must be a 20 back, right?
Yeah.
Backward. And also a baby pushed it with 5 Newton, also not moving. So this time the friction is, the static friction is also 5, right? 5.
Okay.
And
So the
also
5, the static friction is what you push it with.
Yeah, what you push with, if it is not moving. Until maximum happens. Maximum happens, for example, say the highest friction for this one, they must have a limit, right? Say it's the 30 is going to move. So now a champion comes and goes with 30. So now we start to move.
Okay.
Notice that's 30, right?
Mm-hmm.
But after you go with 30, for example, if there's another, greater champion comes, you give it a 40, so now it's totally moving, right?
Mm-hmm.
So this time, this is 40. It's not balancing anymore. Is that mean?
Mm-hmm.
So what we find is that 30 is this one. What we find sometimes, if it is the kinetic friction, there's no problem. Use this formula. If it is static friction, if it is a maximum, you can use this. If it is not maximum, what do you use? If it is not maximum, what do you use? If it is a maximum.
It's the same force.
Yes, use the Newton's first law. Use the, first law.
Isn't that the third law?
I think it's the first law. It's because, for example, I push it, same thing, balancing back. I push with 20 Newton, and the friction give it a 20 Newton, so it balances, it doesn't move. So this is one object have two forces on it. If you talk about Newton's third law, it's between two.
Yeah, Newton's third law is like if you push with something, it pushes the same force back.
Well, yeah, but on different objects. Say, for example, here, in the same situation, there is Newton's third law, but we are not talking about that. See, I push it and I feel the back push, right? Yeah, see, that's the thing. See, but this one, you see the difference between these two?
Okay.
This one is third law. Can you see that? This one? See, I give the block and the block gives me. And this one is all the block feels two forces. Does that mean it's different, right?
Okay.
This is the first law. So, like a static friction, you can also use first law to solve it. And you can also use maximum friction, which is the formula here. It depends on the situation. Does that make sense?
Mm-hmm.
Let's do a question. For example, 13. Let's do 13.
Wait, so wooden floor. So is the friction like before? Like it's 0.3 times the natural force?
Yes, with the 20 times g, right?
Yeah.
Which means 200, which is 660, right? This is kinetic friction, right? No problem with the formula, right? Because it's moving, right?
Yeah.
And now let's talk about B. If the crate is being pulled by a 90 force. parallel to the floor. Find acceleration.
I don't know.
Well, can you draw the diagram for this one?
Okay. The
Yeah, there's a 90 and there is a 60, right? Wait, the other one is 60. The friction is 60, right?
why
Because it's
why is
0,
it 6?
0. Oh, this is the first question. That means you're right, the first question. Okay. So 0.3 times 20 times g. So that's 200 times 0.3, which is 60 Newton. I'm using
Why is
10.
it 200?
It's 20 times 10. I mean, 9.8, you can use 9.8. Does that make sense?
Oh,
The
okay.
gravity.
Yeah.
Yeah, because you have gravity in here, so it balances with the F normal, right?
Yeah.
So 90 minus 60, right?
Mhm.
So what's the acceleration then?
30 newtons.
Wait, 30 Newton is the force acceleration. What's the acceleration? Well, I want A, I don't want a sigma F. This is sigma F is 30. What's A?
Acceleration equals velocity over time. Oh, no, that's
What
velocity times
delta
time.
V? Not exactly. Well, it's if you want to use it, it's delta V over delta T. It's acceleration. And also, you can use Newton's second law. You have
F equals
6.
ma.
Yeah.
Oh yeah, force 30 equals 20 times
Yes.
A.
Yeah.
A
So we
equals,
have 1.5, right?
yeah.
This is 30. I mean, this is 13. See the next one. Oh, next one is static. Let me warn you, next one is static. 14. See 14.
What is the coefficient of static friction? What's the difference of coefficient of static friction and the coefficient of kinetic friction?
Well, this one is moving. It's on the same. For example, it's the same block on the same ground. On the same ground. When it's moving, the mu is 0. Well, it's something. And when it's not moving, the mu is something. Does that make sense? It's a little bit different. Not much, but a little bit different. This is mu static, right? Now you have to choose. Is it mu static time Fn, or is it first law? There are two kinds of ways to do this. It depends on. So let's find the maximum. If your force is enough, yeah, sure. Can you find the maximum static force friction? The formula is find the maximum, but not exactly this situation. But we need the maximum anyway. So can I find the friction? Static. So mu Fn. It's just mu static, basically. What's this mu Fn then? What is the
That's
mu?
just 0.4 times
Yes.
natural force. That's just gravity times.
Which means 100 times 10, which is 1,000, right?
Mhm.
Which is 400, right?
Mhm.
See, which means maximum you can provide 400 Newton. If you don't give me 400, I don't move. And now you're giving 250. What do you think is the friction? Well, what will happen? Do you think it's going to move?
No.
Right? It's not enough, right? So not enough. So not moving, right? If it is not moving, what is the friction now? You give it a 250. If it is not moving, what's the other friction then?
250.
Yeah, 250. So not 400. 400 is the maximum, right?
Mhm.
Does that make sense? This is the difference between this. Which means if you give me more, for example, if you give a 300, it's going to be 300, right? If you give me 350, it's 350, right? Until 400, it's always going to be the force that you give, right?
Yeah.
The one that you pull for this one, I guess. Is it making sense? So
Yeah.
static friction, you have to think about it, right?
Mhm.
We know the formula provided is the maximum one. But whether it's a maximum, you have to depends on the situation of the real situation, right?
Yeah.
So this is the friction. The kind of friction one is static. Oh, this is the one we did it. We did 19. Oh, we can do all the questions basically. We basically finish all of them. Wait, I probably have to explain one word. Do you know inertia?
Is it like the thing like if you go like if you're in a car and suddenly stops, you go the opposite direction?
Yeah, that thing. Yeah. So which means you have the tendency to keep your motion, right?
Yeah.
You said that in previous class. So that's why Newton's first law is called law of inertia, right? Because you have the tendency to remain. If you have constant velocity, you have constant velocity. If you at rest, you're at rest, right? What else? Let's go back to the. Of course, the homework for this one is just chapter 5. You can because we have another week to go, right?
Yeah.
So chapter 5 and chapter 4, is that okay?
Perfect.
And also they have the actual.
Wait, what do you think is the hardest part of like AP Physics 1?
The
Like,
physics
which are the hardest chapters?
one.
Because we don't have to go through all of them right now. We have a 1 week, right?
Yeah, I have 2 weeks.
Oh, yeah.
4 classes. Maybe, yeah, 4. We have 2. Well, right now it's just projectile is a little bit difficult. It's that knowledge is not that difficult. It's just when you meet the question, you gotta think. You know?
Wait, hold on. Go down.
Huh?
Hold on a second. Wait, hold on. How do I?
Projectile is a little bit difficult. I mean, the real question about it.
Can you accept for a second?
Huh?
Yeah. Hold on. Wait, how do I scroll down? Is energy hard?
Yeah, energy is a little bit difficult. Yeah.
What about momentum?
Momentum is okay. Simple
Harmonic
harmonic,
motion.
yeah, simple harmonic is a little difficult. And
Or
rotation is a little difficult because it involves with the with angular velocity.
oh yeah. So basically, I've got kinematics.
4, 5, 3. You finished.
Yeah. Circular. So do we start like I'm gonna do chapter 5 questions and next
4, 5. Yeah, 4, 5.
Yeah, next class we're gonna do circular motion.
Yeah,
Okay.
circular motion.
Okay.
And circular and energy, they got combined. You have a little difficult problem. And then simple harmonic motion and torque is a little, well, they just learn it a little too fast at that time. Okay. Do we have other questions?
No.
Oh, actually, the homework is not just 5. Since
4.
you have 4 or 5. Can I throw in like a 3? 3 is the vector.
Wait. Can we do like 1 or 2 more questions? Can we start it a little late? Or
Yeah, sure.
all right, thank you.
Oh, you mean about this class, right? Okay.
Yeah.
I have 5 more minutes.
Okay. I don't want to take up too much of your time.
No, it's okay.
Yeah.
I want to, since like for physics class, a lot of people don't really like it. They like your attitude that you like physics.
I like physics. I don't like chemistry. I think chemistry is a bit hard.
Okay, great. Yeah, we're on the same boat. I also don't like chemistry that much. Okay, let's see. We can do the free response. Normally is the difficult question. It's just a little long. You can't erase this. Different.
The free response, I feel like it's just like a lot for kinematics and like Newton's laws, just describing things.
Yeah. Maybe two. Question 2.
Okay. In the diagram below, a massless string connects two blocks on a frictionless tabletop. Force F pulls on block 2. So all the forces acting on block 1. So first we got the neutral gravitational, and then so because F2 is blocking and there's no friction, so it's just F2 pulling on it.
Yeah.
So it's going that way.
Mm.
Right?
Yeah.
So oh my god. It started raining again so bad.
Oh,
Okay.
it's everywhere.
Yeah.
Almost
Block
everywhere.
2. Force pulls on block 2. So because we have this and this, there's a force pulling on this, but
Yeah.
also because block 1 has a mass, so it's pulling it backwards.
Yes. Very nice.
Okay. Acceleration. So I think we can do F equals ma. Am I right?
Yeah.
So acceleration is force equals to mass times acceleration. So block 1 is basically let me see. Because it's pulling it, so I think it's like m2 minus m1 minus m2. Or no, m1 plus m2. Right.
Yeah. Okay.
Oh no. That'd be fast acceleration, but it's not gonna be fast. It's gonna be m1. Hold on. Is it m1 minus m2? Or is m2 minus m1 times 8?
Well, you're using a system, right? Are you using a system? Are you
What do
using
you
the two block as a system? Are you using that?
Yeah, because I don't
You think them as a system? If you think that as a system,
yeah, it's a system.
if you think of a system, it's kind of easy, but you gotta be careful. If you think about a system, as I said, as a poly question, think about it's very tight, very short string between them. So that's basically one, right? But now, if that's the case, it's just kind of like a big one. It's just m1 plus m2. That's the
Yeah.
big mass, right?
Then that's m1 plus m2 times acceleration.
Yes, you can use
Okay.
that. If you think about a system, you should think probably like this.
Okay.
Mm.
Because I thought because m2 was also a mass, it could like
Yeah,
reduce the acceleration a bit.
yeah, yeah.
Okay, and what's the tension in the string? How do you calculate the tension?
Yeah, that's the thing. Even if we think about a system, we still have to think about it separately. Remember that poly question I said you have to think about the system. You also have to think about it separately, right?
Yeah.
Let's do this separately.
We never like calculated the tension.
Oh,
It was
yeah,
just
yeah,
we
yeah,
eliminated it, right?
yeah,
So
yeah, yeah, yeah. When you get the acceleration, you can, substitute back. You could get the tension. So acceleration is F over, m1 plus m2, right?
F m1 plus m2. Yeah, that's the acceleration.
Yeah. And then when you think about tension, you want to talk about m1, you talk about m2. Tension basically the same. The magnitude is the same. It's a different direction. Does that make sense?
What do you mean?
It's like when you draw the first question, question A and question B, and you already did that. The tension in here is going for there, right?
Yeah.
And then you're going for there,
So
right?
that's the tension.
Yeah, and this one tension for this one's tension the same magnitude as this one and going there. Right?
Yeah.
So you want to think about block 1, right? Because there's
Yeah.
less force in there. You can use block 2. They're actually the same result.
So basically, the tension we're calculating is how much this going there.
Yeah, basically. So what is the tension then?
That's just the acceleration. No, the velocity.
Wait,
Right.
what do you mean acceleration? We don't use velocity here yet.
No. I mean, like, the force going there, that's the tension, right? Then how do we calculate that?
So it's basically the sigma F is my tension, right? That's the only force that giving the acceleration, right?
Yeah, normal and gravitational force cancel out.
And since in question C, my acceleration is done by F over m1 plus m2. Does that make sense?
M1 times, oh,
That'll be the case, right?
okay. Oh yeah, force F equals ma. Oh yeah. I get it. Yeah, okay.
That'll be D.
Okay, yeah. Okay, if the strings connecting the blocks was not massless. Okay, so there's a mass for this string.
Yeah.
Then we can we like hold on. Then it would just add a force like F over m1 plus m2 plus m3.
Yeah, plus m. Yeah,
Yeah,
plus m.
and that's just the acceleration.
Yeah.
The difference between the strengths of the force that the connecting string exerts on block 2. What? So what? It's like the force here and here, the difference.
Yeah, if the mass is not zero, if the mass of the string is not zero, that'll be the case. Does that make sense? Well, let's just say if there is a difference, let's just find them. First, let's find the strength between the strength of the force that connecting the string exerted on block 2.
Yeah.
Which means what's this force? That's tension.
That's the tension. Yeah.
What's that tension? How do you find it?
Wait, we got a tension on the first block here.
Well, that's the other situation. E situation changes a little.
Is it like one is minus m, one is plus m?
Oh, not exactly. Let's just let me get m2 out. So if m2 is here, so the force is still F, right?
Yeah.
That one doesn't change. But the tension is changing, right? Since in his, from the way that he described it, it's changing. Let's say it's changing. So this is T1 or M2. This is T2. So this is T2. So my F minus T2, it's gonna be my M2 times my F over M1 plus M2 plus M, because that's the new acceleration, right? And that acceleration is the acceleration for everyone, right? Does that make sense? This is the new acceleration, right? Does that make sense? Oh, let me write it. F minus T2 equals to M2 times A, right?
Yeah.
And your A is this, right? Your new acceleration is this because you throw in another M in there, right?
Yeah.
So now I can have my T2, right? And my T2 would be just the F minus F2A, right? Which is F minus M2, F over M1 plus M2 plus M. Does that make sense? So this is focusing on M2, right? And let's read this one here, the other one. So the strength of the force that's connecting string exerts on block 1. So here is the block 1 tension.
Yeah.
It's a little bit different than previous ABCD, but it's a little different. So now I have T2, all I need is T1, right?
Yeah.
So T1, I'm gonna write T1 in here. So T1 is gonna be the sigma F for M1, right? T1 is gonna be my M1 times A, which is M1 times F over M1 plus M2 plus M. Does that make sense?
Then the difference is going to be this minus m2 of f over m1 plus m2 plus m.
Well, I don't really remember that much. So the other one is f minus m2 time f all this, right?
Yeah, m plus m2 plus m. Yeah.
Let me write that again. F minus t2 equals to m2a. So t2 is f. Yeah, sure. And
so
this one, and minus, which one is bigger? I guess it's okay. Oh, let's do that in order. So the
can
first
we
one,
just wait? I have a question. If we
sure,
don't know which one is bigger, can we just write one minus the other with absolute value?
sure, yeah, that's also okay.
Yeah.
Well, if we don't know, let's just do it in order, right? The difference,
Okay.
for example, the difference between A and B is different A minus is A minus B, right? This is
Yeah.
use the first one minus the second one, which is M1 times M1 M2 plus M, right?
Yeah.
So basically, that'll be the answer, and you can just use like a little simplifying, right?
Okay.
Does that make sense?
Okay.
So this satisfies the one that we talk about in Napoleon. This is also one of the a little difficult question. Think about it in a system. Also think about it separately and do all the forces. Does that make sense?
Okay, I got it.
Okay.
Thank you.
So the homework is still 3, 4, 5. Is that okay?
Okay.
And they have answers. If you have questions, they have answer in the end of the book. You can check. It's actually with a lot of explanation there. And if you still have problem, you can just send in the group.
Okay, thank you.
Okay. God bless you. Bye.
Bye bye.
Bye. Oh, you can send the